Hello everyone, and welcome to the second video that will be part of the series about assembly language. And in the second video, we're going to talk about how to add octal and binary numbers together. So we will see that the procedure is really pretty much the same as the one for decimal numbers, so we won't spend much time on it. So for example, let's consider the binary numbers 1, 0, 1, 1, 1, and then 1, 0, 0, 1. So how is it performed? So it's the same algorithm with the addition with carry that we learned like in elementary school. So how does it work? I'll just go it through once, and then we're gonna pass to, just give an example for octal numbers, then we're gonna pass to multiplication. So we have here, we're gonna add digit wise. So we're gonna add 1 and 1, but we're gonna get 0 and with a carry of 1 here. So we're gonna add 1 and 1. It's going to be 0 with a carry of 1 here. This is going to be 1 and 1, 0 with a carry of 1 here, 0, and again 1 here, 0, 1. So let's check that the addition was successful by maybe converting both numbers into decimal and convincing ourselves that it is actually the result of the addition. So the first one was actually 1 plus 2 plus 4, all plus 16. While the second number that we added was 9. So let's see, what we got was 23 plus 9, which is 32. So 32, and this is and this number here is actually 2 to the 5th power. And we see that 32 is precisely 2 to the 5th. So the addition procedure was successful. So as an exercise, you can try adding 1, 0, 0, 1, 1, 1, and 1, 1, 1, 0, 0, 0, 0, 1 together. Now let's do the same procedure with octal numbers. And again, it's the same. Let's consider 631 in octal. So we have 631, and then we're gonna add 4 to 1, maybe. Actually, maybe 4 to 7. Okay, so again here, we're gonna add 1 and 7 first. We're gonna add 0 with a carry of 1. Then we're going to add 4 and 2, that's 6, and then 6 and 4. What is that? That is 2 with a carry of 1, so 1. So all of this, 1260 in base 8. And let's see what is that. That is 8 times 6 plus 64 times 2. That is 128 plus 8 to the cube, 8 cubed. And let's see what the sum of those two numbers were. So it's 8 times 3, which is 24 plus 1 plus 6 times 64, all plus 7 plus 16 plus 8 squared times 4, so 64 times 4. And let's calculate it. And yes, they both match and they're equal to 688. So as you could see, the addition procedure is the same. And now let's look at multiplication. So for example, let's we will only look at it for binary because again, it's really the same also for octal. So I'm gonna look at 10112 times 111001. So let's write it. So here we're gonna again do digit-wise multiplication. So what this will be 1 times 1 is 1, 1 times 0 is 0, 1 times 0 is 0, and then 1, 1, 1. Then for the second digit, there will be 1, 0, 0, 1, 1, 1. So what we did here, we multiplied each of the digits of the first numbers that's getting multiplied by the first digit, and we wrote it here. Then for the second digit, we did the same, but we added a 0 here because of we're multiplying by the digit that's in the second position. Now for the digit in the third position, we're going to add 2 zeros and then start multiplying. But we see that being this 0, we get all zeros. So we get in total 6 zeros after the 2 zeros at the beginning. And then for the last one, I'm going to put 3 zeros and then start multiplying. So that will give 1, 0, 0, 1, 1, 1. And now we add all these together and we get our result. So that's going to be 1, 1, 0. Then this is going to be 0 with a carry. That's going to be 3. So that's going to be 1, with a carry, and this is again going to be 1 with a carry, 1 with a carry, 0 with a carry, 0, 1. So let's check if that was actually the correct answer by converting everything in decimal. So this was the original. This is the result, and then the original, and then the two numbers that we multiplied were 1 plus 2 plus 8, so 11. So it was 11 times, well, 1 plus 8 plus 16 plus 32, which is 11 times 57, which is 627. Now let's check that this is 627. So this is 1 plus 2 plus, well, 16 plus 32 plus 64, all plus plus 512. And summing all of this yields precisely 627. So now you can try exercising a little bit with this algorithm, but I don't even think it's necessary since it's really the same as the one for decimal numbers. So we will now directly move to the next video where we actually are going to talk about computer architecture in a way that will help us in our journey to learn assembly.